Chestnuts, widely consumed in daily life, generate a significant amount of shell waste, which is over 3 times the mass of the edible part and is often disposed of as wet waste, incinerated to release harmful gases that pollute the environment. This observation led me to research using chestnut shells as a material to find opportunities for reuse. In my desktop research on the material properties of chestnut shells, I discovered that the lignin in the shells has the capacity to adsorb heavy metals like lead. Microscopic examination of SEM images of the chestnut shell revealed elliptical pores approximately 15 micrometers across, facilitating metal adsorption. Experimenting with ground chestnut shell samples, I found that after mixing 3 gl of the powder with 10 milliliters of a lead solution and allowing it to sit for 80 minutes, the shells reached adsorption saturation, significantly reducing the concentration of lead in the sample. I continued to think how to work backwards with this characteristic of lead adsorption to find the scope of application. I have investigated that the issue of lead pollution is acute in Southeast Asia, where private workshops often dismantle lead-acid batteries for resale, causing severe soil contamination and posing significant health risks to humans, particularly to the nervous system. Despite lead typically existing in a solid state, it can become liquid and contaminate the soil surface and plants, especially after rainfall. While there are many potential solutions for managing lead pollution, existing applications have notable shortcomings. My approach focuses on reusing chestnut shells as an adsorbent material to develop a machine designed for restoring lands polluted with lead. This project integrates 3 parts: lead collection bottles, collection bottle recycler, and recycler machine carrier. The recycler machine carrier is engineered to automatically identify, place, and collect collection bottle recyclers while also crushing chestnut shells to produce the adsorbent for work of the lead collection bottle. Once placed on heavily polluted soil, the collection bottle recycler releases lead collection bottles to gather heavy metals from the soil, utilizing chestnut shell adsorbents. The collected lead can then be recycled and reused. The process begins with loading waste chestnut shells into the recycler machine carrier's crusher to create the adsorbent, which is then inserted into lead collection bottle by the machine. These bottles are deployed into contaminated soil to collect lead, powered by solar panels. After collection, the recycler processes lead collection bottles, and the carrier transports them for centralized waste management. Through sketching and exploring various designs, I refined the structure of the lead collection bottle recycler, and carrier, focusing on the details and mechanisms to find the most suitable design. This iterative process culminated in the creation of a 3D printed model for practical verification. Additionally, I developed a related application to facilitate automated operations, aiming to reduce the complexity of use. This research not only addresses environmental pollution but also promotes the circular economy by repurposing agricultural waste for environmental remediation.